Let's briefly talk about catalysis and catalysts. So a catalyst is a substance that changes the rate of a chemical reaction without itself undergoing permanent chemical change. So basically, it is often a reactant in the first step of a reaction and a product in the final step of the reaction, meaning that the catalyst itself is not consumed. The way that catalysts work, for the most part, is that they lower the overall activation energy for a chemical reaction. So we lower the E sub A, lower the activation energy, and increase the rate. There are some catalysts that operate by increasing the number of collisions or increasing A, which would also increase the rate. And often those catalysts operate by holding the reactants in place in a way that they can collide and increase the rate of the reaction. So, we are talking about making proposed mechanisms. Well, a catalyst has the ability to completely change the mechanism for reaction. And in doing so, it can make a reaction progress diagram look a bit different than what has initially been thought for a reaction. So for instance, here we have two H2O2 reacting to form H2O and O2. So peroxide is our reactant, water and oxygen are our products. For an uncatalyzed reaction, we need to go up our hill to form products in this exothermic reaction. We have a given activation energy for this reaction. And we have a transition state here at the top of the hill. But if we add a catalyst to this reaction, then we have a whole different mechanism. So here, no catalyst. Here we have a reaction proposed mechanism that occurs with the catalyst. And you'll notice that we have two bromide ion appearing on the reactant side of this reaction and showing up on the product side of the last reaction in this mechanism. That's indicative of a catalyst. So a catalyst shows up in the reactant side, typically one of the first reactions in the proposed mechanism, and then shows up on the product side, typically of the last reaction in the mechanism. So again, the catalyst is not consumed. You'll also notice that now, when we have the catalyst, we have a two-step process. And that is shown, sort of depicted in our reaction progress diagram, where we have a hill, an activation energy for the first step, then some intermediates, and a reaction, an activation energy for the second step, and then on to products. You'll notice that overall the activation energy has been lowered for the reaction. The first step would be the fast step in this reaction with this magnitude of an activation energy. For the second step, the activation energy will be larger, and this will be the slow step of the reaction. But again, two steps, two hills, reactants going to products. And an overall lowering of the activation energy for the reaction.